Okay, we stopped here last time. We was talking about the permanent mold cast or permanent casting process, and the permanent casting process, as I told you, is different from expandable. Expandable, you sacrifice the mold, you destroy the mold, but in case of the permanent mold casting, you maintain the mold for several casting. Maintain the mold for several casting means you create a mold once, and you use this mold to make several casting. We already started this die casting process, the first process in the permanent casting. We call it is a die casting, and die casting is hot chamber machine and cold chamber machine. Actually, we already started this one before, just to remind you. So this is a hot chamber. Hot chamber, we said that it is hot chamber because this is a chamber all time immersed in a liquid. This is the liquid, this is the furnace, and this is a liquid metal and chamber all time immersed in a liquid. The plunger here, the plunger open liquid will get inside, and the plunger push the liquid to fill the cavity in the mold. While solidification, you open the mold and take the part out, and you repeat the process several times. This is very fast process, I mean a mass production process. We call it hot chamber, and it is a mass production process. Can produce up to 900 part per hour. It's very good actually. It's very fast production rate. Smaller product can be produced, also bigger product can be produced. You can control also the cooling rate by adding the cooling channel here in a die. We added cooling channel here and circulating cooling liquid like water or maybe oil, sometime air, to cooling down the part to fastening the process or increasing the production rate or reducing the solidification time. So this is whatever we call is hot chamber. This one we discussed last time, if you remember. So this is a process. You open the plunger, you put the liquid inside, and the plunger here puts the liquid. This is the next step. Plunger puts the liquid to fill the cavity. Then cavity is filled with the liquid. You leave it to solidify. As I told you, we controlling here, controlling the solidification by adding cooling channel here to circulate water or oil to cooling down the part. When the part solidify, you open and take the part out. Most important thing here is that we apply pressure. We maintain pressure until solidification happens. This pressure actually very important to maintain the pressure here until solidification completed. Because while applying pressure here, you're forcing liquid to fill all cavity perfectly, every tiny details here. It filled under high pressure because the pressure applied here by the plunger, as you can see. This one thing. Another thing here, this one solidify, the part in the mold solidify. However, the liquid here still remaining liquid because this part is hot. So this one can guarantee to deliver liquid to compensate shrinkage after solidification. So you need, or it is important to maintain a pressure during the casting process, all time during the casting process until solidification happens. When solidification completed, you release the pressure, liquid will be released, and then you open and take part out. You oiling the system, and then you close, get the cavity again, and you're repeating the process for several times. This is a hot chamber. Cold chamber also we discussed last time. We call it cold chamber because the chamber here not immersed in the liquid. It is in somehow different from the previous process. Chamber here in air, in environment. So it is not immersed in the liquid. That's why they call it is a cold chamber. In a cold chamber here, we're feeding manually. We're feeding liquid manually. So liquid here manually feeding, and then the plunger puts a plunger here to push the liquid to fill the cavity. So it is actually same mechanism, but only different is the feeding here done manually. So it is higher production rate, but not usually fast as a hot chamber. Actually, let me show you a nice video about this one. Let me share it screen. Okay, this is a cold chamber. Cold chamber here, as you can see here, it is not immersed. You put the liquid and then you push the liquid will fill the cavity. Then you open, takes a part out. This is the ejector pan. You oiling. When close, you get the cavity here. When you close, you get the cavity as you can see here. So cavity will be created when you close this one. This is the ejector pan. These are the ejector pan needed to eject the part out. This is the liquid. This is the plunger. This is. Then you put the liquid. Then you pump liquid here. You can see that. You pump liquid. Liquid will fill the cavity perfectly. You maintain the pressure. And then you open when solidification happen. You open it, take the part out. This one release. And then oiling and repeat the process again and again for several times. Okay, this is whatever we call cold chamber. Let me show you actually about the hot chamber and cold chamber in uh, in a company. Right. This is wow, no, not this one. This one is a general permanent move. We talk about the hot chamber and cold chamber now. This is a company. This is a machine. This okay. This is a hot chamber machine. This is a hot chamber machine. It's big machine as you can see. It is very big machine. You see it's costing money, so it is, and somehow the capital cost here is expensive compared with the sand mold casting. This is a plunger. This is a liquid actually. You see that chamber is immersed. This is a liquid. Liquid means this is a liquid as you can see here. Chamber is totally immersed here. This is a plunger. Then it's now slowly, now they make it very slow to show. Now this is kind of the demonstration. This is a liquid. Then the plunger is released now. They take the part out and so on. This is the plunger. It's open now. Then liquid filled inside. When plunger is open, liquid automatically, this is a hot chamber. Liquid automatically will fill inside here. Then plunger come push liquid. Then liquid will move. Then fill the cavity. As you can see, you maintain the pressure. You maintain while solidification. When solidification happen, you open and takes the part out and so on. So this is a plunger and this is hot chamber. The liquid here and chamber is immersed. You cannot see because it is immersed in the liquid. So this is the hot chamber. The other one is a cold chamber. Now we going to the cold chamber machine. It is very hot also, but they call it cold chamber because it is not immersed. Here, this is a piston. This is a plunger. This is a feeding system. This is a robot arm to feed the liquid. Then liquid here. We put here in. This is a chamber, cold chamber here. Then we put liquid manually, as I told you. The big difference is we pouring liquid manually, pouring liquid manually in the cold chamber, and then plunger. After you put the liquid, plunger push the liquid to fill the cavity. Then get the process done, get the part is completed, and so on. So this is a cold chamber machine. So this is a plunger as you can see here. After you put the liquid, this is a plunger here. A plunger here puts the liquid fill all cavity as you can see. While solidification, it takes the part out, and then this one will release, and then you start the process, you repeat the process again for several times. Yes, Abdullah.
Doctor, how they manage to not get stuck with the plunger؟ يعني
How
كيف
they
إنه
manage
إنه نفس المثل مو هو يكون ذايب مع الوقت
هو
ما
liquid.
يجمد. إيه
هو liquid metal because this one is very hot actually. This area is very hot. Even this we call it cold chamber, but it is very hot. And then when you push it, it's happened in a fraction of second, very fast. it's not that long time. Solidification take longer time, right? So it's happened in fraction time. So this one is still remaining liquid. This one, when you put liquid again, because when this one will release and put liquid again, all will be liquid here, and then a process will happen in very short time actually.
تمام.
Okay, so yeah, this is what they call is a cold chamber, and this cold chamber actually can cast aluminium, brass, and magnesium alloys. If you realize that, you find that aluminium, brass, and magnesium alloys are higher melting temperature than the other one being used with the hot chamber. Hot chamber, tin, lead, and so on, lower melting temperature material. So this is the big advantages of cold chamber over hot chamber, because here, why you ask me why here we can cast higher melting temperature in cold chamber that we cannot cast actually, or we usually avoid to cast in a hot chamber, because hot chamber is all time immersed in the liquid. If you melting or if you casting higher melting temperature material, probably chamber will be damaged. But in case of cold chamber here, no issue, because it is in environment, so it can cast a higher melting temperature material. So this is a big advantages of hot chamber over, cold chamber over the hot chamber, that which is hot chamber can only zinc, tin, and lead. However, cold chamber could be used for aluminium, brass, and magnesium, which is a higher melting temperature. This is the advantages of cold chamber over the hot chamber. However, cold chamber is a higher production rate also. Cold chamber is a high production rate casting process. However, it is not high like hot chamber. Hot chamber is higher. Why? Because hot chamber is feeding, automatic feeding of liquid, but here manual feeding of liquids make it the process is slower than in a hot chamber. This is the big difference between hot chamber and cold chamber. This is a machine, as you show in the video. It is very big machine, and it's very expensive machine. It makes this process not cheap actually. It is costing a big amount of money compared with sand casting. Sand casting is very cheap, because almost you make the mold of sand, and making mold almost costing very little amount of money, and no machine, no anything. So compared with this one, usually sand casting is very cheap. This one usually is expensive. That's why permanent mold, always we say that permanent mold cast is usually used for mass production rather than used for smaller, like don't use it for example 2 or 3 or 5 or 10 parts. That will not be economically visible, right? Cold chamber, here is a process. As you can see, there's a cold chamber. You put the liquid inside, you push the liquid to fill the cavity, and then you open, it takes the part out. This, whatever we call, is the ejector bin. Ejector bin here is very important, needed to push the part out, then part can be easily removed from the chamber, right? Material to be used to manufacturing the mold, or mold material. This is the mold. Mold material usually made of steel, marginic steel, and also cast iron to cast lower melting. Be careful. It must be used to cast lower melting temperature material. It means that you cast aluminum in steel, you cast, for example, magnesium in steel, you cast whatever material lower melting temperature in steel. However, if you would like to cast steel, you need to use a refractory like tungsten or molybdenum. So tungsten or molybdenum are good refractory material used to die cast steel and casting iron. Usually tungsten and molybdenum are material, we call it refractory material. So this refractory material is good, higher melting temperature. So you can use to cast iron or cast steel. Ejector bin here, very important. This is actual photo. This is actual photo of the die, and this is the ejector bin. So ejector bin here, when you push, then the ejector bin used to remove the part out. It is very important. Lubricant also must be added to prevent sticking. Don't forget, always lubricant is needed before you do the casting to prevent sticking in casting or to easily remove the part of the casting process. Advantages and disadvantages, or general advantage and disadvantages of die casting, either for cold chamber or hot chamber. You can see that economical for large production quantity, as I told you. This is not economically visible for lower production quantity, but for higher production quantity is considered as economic, good accuracy and surface finish. Why? Because it is good accuracy and surface finish because the mold is made of metal, mold made of metal. No diffusion happen between liquid and sand as we have in sand casting. No layer on the surface mix between sand and liquid because it's made of metal. So now the metal is separated. Then surface quality and accuracy also is good. One will say me says, why accuracy is good? This is kind of shrinkage will happen. You melting the material solidifies and shrinkage will happen. Accuracy will be affected. Yes, it is, but in a permanent mold, actually, when you apply pressure, when you pumping liquid to fill the cavity, you maintaining liquid all time. When you maintaining liquid under pressure all time, the pressure will force liquid to fill cavity perfectly. This is the one. This one leading also full dense casting and very low porosity casting, and also maintaining the pressure here allow liquid to deliver from here to compensate any shrinkage happens. This one definitely will improve accuracy and surface quality. Meanwhile, also thin section is possible because you have applying pressure here, you are applying pressure. This high pressure push the material to fill all cavity perfectly. Even thin section also possible by using this method compared with the sand casting. Probably sand casting thin section very difficult, maybe viscosity and surface tension not allowing or not possible with sand casting due to the viscosity and surface tension. It is not possible using sand casting to create thin cross section, but here because of the pressure, high pressure during the process, this kind of thin section is possible. Rapid cooling rate compared definitely with the expandable mold casting. Rapid cooling because the mold is metal, made of metal, the mold made of metal, then it is a rapid cooling process. This is one. Another one we can add it here, cooling channel to circulate liquid or oil, then increasing, so we can controlling the cooling rate. It means that smaller grain structure, higher hardness, good strength in casting. Definitely we can control the mechanical properties of the part. Actually, we can make it slow cooling also as well. We can make it slow cooling by circulating hot liquid. If you circulating hot liquid, you can make the cooling rate is very slow. If you circulating cold liquid, then you can make it very fast. So you can control the cooling rate, and definitely this leading to different mechanical properties. Disadvantages, the main disadvantage here is money. This one is expensive compared with the sand casting or expandable mold casting. This one is more expensive. This one limited to lower melting temperature material, means that if you use steel to manufacturing the molds, then you have to cast lower melting temperature material. And also geometry here is simple geometry can be created compared with the sand casting or expandable mold. Definitely can create the most complicated part by using expandable mold. Permanent mold is very difficult because you have to facilitate to take the part out when you complete the casting. So if you try to make a complex part here, it may be difficult to take the part out after the casting completed. So this is the disadvantages of the die casting. Okay, next we talk about the squeeze casting. Okay. Squeeze casting. This is another expandable mold casting. We call it is squeeze casting. Squeeze casting actually we call it semi-permanent, semi-solid casting process. Semi-solid casting because the liquid here we deliver liquid here in the squeeze casting. We deliver liquid here as a mix between solid and liquid. We deliver the liquid material here as a mix between solid and liquid. We call it is a mushy zone actually. We call it is a mushy zone. Let me show you which is a semi-solid casting. Semi-solid casting, we deliver liquid as mushy state. This is a solid, this is a solid, this is a liquid. In between we have solid liquid. We deliver liquid as a mix between solid and liquid, so we call it semi-solid metal casting. And in this case actually, as it is mixed between solid and liquid, then the cast here will be squeezed because the material will be deformed. It's kind of mix between casting and forging process. When you apply pressure, this is a die. When you apply pressure using the upper die, applying pressure, material will be forced to deform. So it's kind mix between casting and forging process. This is a part, as you can see here, produced. This is the benefits of having this one complex part geometry, or more complex part geometry can obtain. Thin part wall also possible. Close tolerance can be done. Zero or low porosity resulting in light strength in casting can be produced. This kind of the advantages of the semi-solid casting process or the squeeze casting process. Next is important actually, we call it centrifugal casting. Centrifugal casting, it's coming from the centrifugal force. I will explain what is that mean. And we have three group of centrifugal casting: true centrifugal casting, semi-centrifugal casting, centrifuge casting. Okay, one by one. True centrifugal casting. True centrifugal casting, it happen, this whatever we call true centrifugal casting, it happen when you rotate certain part. This is a mold actually. This is a mold. When this is a rotating mold, you put liquid here, and this is a rotating mold. This is a rotating mold like this one. So you put liquid here. This is a liquid. You bring liquid inside a rotating mold. This is a mold, and this mold is rotating. So this is a rotating mold. For example, like this. This is a two roller. The functionality of this two roller is to rotate the mold. So mold is rotating, as you can see. Mold is rotating. Mold is rotating. And you drop liquid inside. When you drop liquid inside, by the effect of the centrifugal, we call it is a centrifugal force. When this part is rotating, due to the centrifugal, the liquid will stick with the wall due to the centrifugal force, because this one is rotating. Due to the centrifugal force pushing this one upward, and gravity inward. So centrifugal force pushing liquid upward here, and gravity inward. If the centrifugal force bigger than gravity, then the liquid will stick with the surface. Liquid will stick with the surface, as you can see here. So when you drop liquid inside while this one rotating, liquid will stick with the surface. While solidification, you create, this is the yellow color. Can you see that? This is the yellow color is the cast. When you put the liquid while this one rotating, liquid will stick with the surface. While solidification, you get this one, you get tube. This is a production. So this one is rotating here. This is a two roller. This is a two roller. This is a mold. You put liquid inside. You put liquid inside. Then liquid will stick with the surface, as you can see. While solidification, when solidify happen or solidification happen, you get this one. You get tube. Yes, Muhammad.
دكتور العجلتين الدرايف رولر والفري رولر وينهم بالصورة اللي بالنص؟ الصورة اللي بالنص تحت ما وين العجلات؟
اهي وهي.
على اليسار.
This one and this one. This one is a drive. This one is a free.
الصورة اللي جنبها.
لا، الصورة اللي جنبها احنا مش مبينين دول، يعني احنا بينا التيوب، هم بيسحبوا التيوب دلوقتي. فانا عايز اوريك ان شكلها عامل ازاي يعني، لكن هو انت شوفهم هنا يعني. هنا ادي واحده ودي واحده. This one and this one, right? The functionality of this two roller is to rotating this one, right? To rotating this one. So when this one is rotating, then liquid will stick with the surface to create the cast, and this is the cast. Now they're trying to take this one out. Is it clear? You understand?
Yes, clear. Thank you.
Yeah. Okay. Any other question? Right, so this whatever we call centrifugal casting, because here why we call centrifugal? Because if this one is not rotating, if the mold is not rotating, nothing will happen. Just imagine if no rotation, no centrifugal force, liquid will never stick with the surface to create the tube. That's why they call it centrifugal, because centrifugal here is essential to make the castings, and that's why they call it centrifugal casting. So molten material is poured into rotating mold. It must be rotating mold, produce tube part. That product is a pipe, tube, washing and rings and so on. Outside shape of the casting can be round or can be hexagonal or whatever. Outside. Inside must be circular, but outside could be circular, could be not circular. No problem, because it will fill the cavity. The outside shape will fill the cavity. Doesn't matter what is the cavity, but internal surface usually is circular shape. Right. This is a centrifugal force. So centrifugal force, as you can see here, you drop liquid inside. When you drop liquid inside, this one is rotating. This one is rotating. So when this one is rotating, this is a centrifugal here. So this one is rotating. Then we have here centrifugal force outward, gravity inside. So this is a force actually, force, centrifugal force affecting like this, weight of the liquid affecting downward. So centrifugal force equal to m omega square r, or mv square divided by r, because omega equal to vr. So it is equal to centrifugal force equal to m omega square r, or m omega square r, or mv square divided by r, and gravity force here, which is a liquid weight, equal to mg, mass of the liquid, multiplied by the gravity acceleration. Then you have two forces, one upward, one downward. If the please give me your attention, if the centrifugal force bigger, then you will get the cast. If weight bigger, then you will not get the cast. To get the cast, centrifugal force must be bigger than the weight of the liquid, right? You can see that the centrifugal force affected by velocity, rotational velocity. Whenever you increase the rotational velocity, omega, whenever omega increase, force increase. So we need to actually increase up to certain speed. If the speed lower than certain value, weight will be bigger than force, then no liquid will happen. But we need to increase the speed up to reach to certain limit. Then you can say that, yes, force, the centrifugal force bigger than the weight, then centrifugal force bigger enough to maintain the liquid, or to keep the liquid stick with the surface of the mold to create the cast. Then we have what we call, because of that, we have whatever we call is the G ratio or G factor. It is equal to F divided by W. F, which is equal to mv squared divided by r, and W equal to mg. So this is a W here, equal to mg, and this is the centrifugal force here equal to mv squared divided by r. So this is the equation. Then you can see that m goes m, then you get v squared divided by rg. This is the G ratio. Definitely, as you can see, G must be bigger than 1. You agree with me? G must be bigger than 1. If G is smaller than 1, then you will never get the cast. Actually, they would like to keep G between 60 and 80. Somebody said this number is very high. Yes, to get the perfect cast and get full dense casting. To get full dense casting, a low porosity casting, and the perfect cast, G usually not only bigger than 1, but usually G range from 60 to 80. It's recommended like this. This is a recommendation in centrifugal casting. So F equal to mv squared divided by r, G equal to F divided by W, and finally G equal to V squared divided by R. V squared divided by RG. V square. V is the rotational speed, R radius of the cast, G is gravity acceleration. V here we can replace V by R by dN. Here, as you can see, this is here, V here is hour. We divide by 6 to make it minute. We divide by, this is by hour, this is V here is meter per hour. Then we need to make it minutes, then we divide by 60. And it is by the n, then make it R divided by 2. By Rn multiplied by 2, then 2 by Rn. 2 by Rn divided by 60 mean by Rn divided by 30. So this is the V, then this is the V value. This is the V value here. V value here, we divided by 60 to make it minute. Then 2 by Rn or by dN. By dN or 2 by Rn. 2 by Rn divided by 60 mean by Rn divided by 30. Square V square divided by Rg. Okay, then this R go with 1. This is R squared, this is R. Then R taken out, multiplied by N divided by 30. Squared divided by G. Then we need N. Actually, because N is very important, RPM is very important, because Rn shows a limit. Up to certain speed or RPM, cast will not happen. We need to increase the speed, we need to increase the speed, we need to increase the speed. So this one will satisfy the condition. Then N as a function equal to, from this equation, we can say N equal to 30 divided by 2GG divided by D. 30 divided by square root 2GG's gravity acceleration. This is a G factor divided by D. This is the N equation. Actually, this is very important. So we can identify what is the speed required for the centrifugal casting. So this is the N equation to obtain what is the needed speed or RPM to do the casting, centrifugal casting. Okay, G, as I told you all time, G is usually they would like to maintain between 60 and 80. Recommended, it is recommended actually, or standard being used as 60, between 60 to 80. Example, let's see an example. I try to solve the example together. Through centrifugal casting operation. Through centrifugal casting operation is to be performed horizontally. As you can see here, this is the one horizontally. Horizontally mean the axis of rotation is on horizontal axis. So it be done horizontally. To make a copper tube section, outer diameter 25, inner diameter to 2.5. What is the rotational speed? If G factor is 65, G factor 65, so what is the needed rotational speed to do this casting process? Then put the equation, immediately put the equation equal to, this is the equation as I told you, 30 divided by square root 2GG divided by D. Then here you can see 30 divided by 2GG, 2G is gravity acceleration, G here 65 given, divided by diameter here outer diameter of the cast or inner diameter of the cylinder, outer diameter of the cast or inner diameter of the mold, which is 0.25 meter. Then you can obtain, this is RPM, 681 RPM. We need RPM to be at least 681 to obtain or to achieve the casting process or centrifugal casting process. Right? Any question? Okay, I hope it is clear. Actually, not only horizontal but also vertical. Centrifugal cast could be also done vertically. As you can see here, this is vertically. Vertically, this is a mold, rotating mold, and this is a liquid. We deliver liquid here, then liquid here, because of rotational, the mold rotation, liquid will stick. It is less common actually, less common compared with the horizontal. Mostly horizontal centrifugal casting, but some special cases, very special cases, they do vertical but lengths not big, usually with a smaller length. Bigger lengths usually horizontal centrifugal casting. So in vertical, equation is a little bit different. Then equation equal to 30 divided by pi square root 2gl. L here is the length, L here is the length, as you can see, divided by RT square. RT square is the internal or inside radius at top level. RB square, internal radius at the base level. Definitely RT and RB are not same. You can see that because of the gravity. Because of the gravity, usually the radius, the bigger radius, the top radius is bigger than the radius at the base. You can see that radius at the base usually, I make it exaggerating, I mean to show you, usually radius at the base smaller than radius at the top because of the gravity. Yes, this one is rotating, but still radius are not exactly same. There are some difference between RT and RB. Using this equation, you can obtain the RPM needed in case of vertical cast. As I told you, it is less common compared with horizontal casting. Next, we have what we call is the semi, listen to me carefully, semi-centrifugal casting. The previous one, we called it as true centrifugal casting, and now we call it semi-centrifugal casting. Why we call it semi-centrifugal casting? Because casting here, please listen to me carefully. Casting here, or the centrifugal force here, not essential for casting. What does that mean? It means that if there are a centrifugal or no centrifugal, cast will happen. For example, like here, you put liquid, if no centrifugal, if this one is not rotating, this part is rotating. But if not rotating and no centrifugal, you put liquid will fill all cavity and cast will happen. No issue. So why we use the rotational here? We're rotating the bar. Why are you rotating the bar? We're rotating the bar to push the liquid. It's kind of assisting the casting process. Assisting here, not essential, but assisting. Then we help liquid to, because it's centrifugal will push the liquid to move to fill cavity perfectly and creating a higher dense or full dense casting, a low porosity casting. This is the main reason. So in whatever we call here semi-centrifugal casting, centrifugal is not essential, but it helping the casting process, right? So this is whatever we call is a semi-centrifugal process. And here again also this semi-centrifugal, you put the liquid, this one is rotating. We're rotating the mold, but either we rotate the mold or not rotating the mold, cast will happen. But when the rotating mold, you get more or full dense casting, low porosity casting, and also higher quality casting, because the rotational motion here or centrifugal force here will push the liquid, as you can see here, push the liquid to move and fill tiny pieces. Smaller section can be produced and better quality can be produced by using semi-centrifugal casting. This is whatever we call semi-centrifugal casting, not true centrifugal. There are another one we call it is a centrifuge casting. It is a bit different from the other two methods. Centrifuge casting is a little bit different. How different? Centrifuge casting is a way to deliver centrifugal. We need centrifugal force. As a method to deliver liquid to a far place. This is a mold here, as you can see. A mold is somewhere far from the pouring place. We need here the rotational motion or centrifugal force to deliver the liquid, to bring it to the mold, which is somewhere else, a little bit far from the pouring place. We call it, it's not very common not very common, but it is a method, we call it is a centrifuge casting. This is the difference between the three cases of the centrifugal casting process. Right. Next, we have whatever we call is the slash casting. Next is the slash casting. Actually, slash casting is a nice way of casting being used with the sculpture to manufacturing sculpture and so on. In the slash casting, this is a liquid, for example. This is a liquid. When you leave the liquid to solidify, starting solidification start from outer surface to inner surface. It means that outer surface becomes solid, inner surface is still liquid. If you leave more time, 5 seconds, 1 minute, you can see that the thickness will increase, still inside is liquid. 2 minutes, bigger thickness you get. 6 minutes, bigger thickness you get. Still internal core is liquid. So what is the slash casting? Slash casting, actually, in the slash casting, we use this kind of fundamental. We put liquid here to fill the cavity. Then we put liquid to fill the mold cavity. And then when we leave it for a while, you can see that a layer will be start and then thickness will increase. When we reach to the desired thickness, we invert this one. يعني نقلبها يا شباب. We invert this one, then we drop the remaining liquid inside. Only the outer layer will be there. Someone will ask me why we do this. You get hollow casting structure. Something like this. Then you get outer, when you see from outside, it is totally complete, but inside it is hollow. So it is outside full and complete, but inside it is only layer and we drop the liquid inside. Why we do this? This one, those guys who working with manufacturing or doing the sculpture, making sculpture التماثيل يا شباب. التماثيل اللي هم الفنانين اللي بيعملوا التماثيل. They are interesting to do this. Why? First to save the liquid, because no need actually. What is the benefits to have full structure here inside, complete? No benefits. They only need the outer shape, so they would like to save the liquid. Not only that, but weight also. This one less weight. Other one, if you make it full complete with metal, then it will be very heavy, and no need actually. Then they drop liquid inside and maintain only a hollow structure, as you can see here. For sculpture تماثيل، يعني في تصنيع بيستخدموها في تصنيع التماثيل زي ما انتم شايفين. Okay. Next is the low pressure casting. Low pressure casting is another permanent mold casting. In a low pressure casting here, this is a mold actually. This is a mold. They usually apply pressure here. They eject gas, maybe air under pressure. Then this gas, when they eject, push liquid, then liquid will move up and fill cavity under pressure. Fill cavity in the mold here under pressure. They call it it is not very high pressure, but enough to push the liquid to fill the cavity perfectly, and it will be under pressure. Okay, let me show you this one. Let me show you this one, low pressure casting. Okay. This is a low pressure casting. Here you put a liquid. From here you put liquid. Liquid metal, definitely liquid metal, the metal that you, this is a mold, this is a cavity. You put the liquid here, and then when you finish, you close, and then you pump here gas. You pump gas under pressure, or air, or whatever. Then gas will push here, liquid will move up, fill cavity here perfectly. And because it is under pressure, this metal will be, porosity is somehow less, and also you get good quality, surface quality, and so on. Right, get back to the slide. So as you can see here, we use the pressure or gas pressure to do the casting process. However, the problem is sometimes gas trap inside. Sometimes the facing problem here, which is sometimes gas trap inside and creating little porosity in this case. To improve the condition, they make it is a vacuum permanent mold casting. This is the improvement of the previous case. In a previous case, as I told you, we're pumping gas. When you're pumping gas, sometimes gas trap inside and create porosity. But here vacuum mean negative pressure. No pressure, but negative pressure. Then this is a liquid. They put the liquid here, it's closed, and then they apply negative pressure. When they apply negative pressure, the liquid will move up to fill the cavity, as you can see. And this is better because no pressure being applied here, no gas trapped inside. This one producing full dents and very less porosity compared with the previous case. So there are air porosity can be reduced, defect can be reduced due to the porosity. A greater strength is given because definitely quality will be better than quality in the, this is a vacuum compared with the over the case of the low pressure mold casting. This is the end of the permanent mold. This is the end of the permanent mold. Now we're going to talk about the foundry practices and furnaces. Foundry practices and furnaces. Actually, time is finished. I think I have to stop here. Then I'll stop